Hello, ladies and gentlemen. Today, I just want us to quickly look at how to use R to run a logistic regression and to perform some diagnostic tests. The starting point, as we are all aware, is to set our working directory. I want to use logit file on my desktop. Logit file on my desktop as my working directory. That's okay. Then the next thing is to load necessary packages and the data. So we want to make use of ISLR, summary tools, tidyverse, broom, car, PSL, and MFX. Quite a number of them. So let's run. That's okay. Then we want to make use of data sets defaults. The data set can be found in ISLR package. So let's run it. And you want to know details of the content of the default data set, then you run, just put asking question, then you run it. Okay. So the default data set is credit card data, and it's a simulated data set containing information on 10,000 customers. And the basic aim is to predict which commerce actually will default on their credit card. So in terms of the variables, we have defaults, which is a factor level with no or yes, indicating whether customer defaulted or not. Then we have students, whether the customer is a student or not. Then we have balance, which is the average balance that the customer has on their credit card after making their monthly payments. Then we have income, which is the income of the customers. And you can download this reference. Actually, you want to learn more about the data sets. So let's look at the descriptive statistics of the data using DSCR function in summary 2. So, and we are going to view the results. I put summary tools here with view because view could be, it's possible you have view in some other packages apart from summary tools. So I have summary tools here, then view. So then this is my descriptive statistics, and I want it to be in the working directory. So let us run. Okay, I already have the result here. So this is the descriptive statistics. Here we have mean, standard deviation, minimum mean, and so on and so forth. But for the two predictors, balance and income. Then we want to get the frequency distribution. For defaults, we use freq function. Then we follow the rules actually in order to view it. So let's run it. So if you have done it, then you get these results here. So this is the results. So we have no, yes, and we have the percentage, the cumulative percentage. Now let's move straight to our logit model. Logit is one of the generalized linear models. So So we use GLM as a function. So we have default, which is our dependent variable. Then we have two predictors, balance and income. Family is binomial. Then data equals to default. If you want to run probits, it is the same procedure here. The only difference is that in front of binomial, you will put a bracket. And inside that bracket, you will write link equals to probits. But here we are dealing with logit. So just straightforward to do. Then let's run it and get our results, which is the summary here. So you run it. So if you have done it, this is our results here. By way of interpretation, 5.64 multiplied by 10 raised to the power minus 3 and this and the income. These are log odds. And I used to tell students, you see, we hardly think in terms of log odds. People think in terms of odds or probabilities. So it's very, very good to obtain the predicted probabilities as well as perform marginal analysis, or at least obtain the odd ratios, which and those ones are easier to interpret than log odds. So let's come to predicting the probabilities. So to predict the probabilities, I have here default dollar probabilities. The reason why I put dollar here is I want the probabilities for all the 10,000 customers to be within the default data sets. So I have it here, predict model 1 type equals to response. So we have done that. We have the probabilities for the 10,000 customers. Then if you put edge this here, then we have the result for the first 6 customers. So let's run it up to this level and see. So here we have the probabilities for the first 6 customers. Now we can see that the probabilities of default actually for all of them are very, very low. So then I may want to categorize my customers into positive customers, negative customers. If your probabilities, for instance, is greater than 0.5, then I want to classify you as negative because the probabilities of default is very high. And if your probabilities is less than 0.5, I want to classify you as positive because the probability of default is actually low. So, and I want this, I call it spread cut, and I want it to be in my default data set. So, and let's run it. Run. So this is clearly showing us that the first 6 customers are actually classified as positive customers. The probabilities of their default is very low. Then I can write the whole of the new default data set in Excel. This is what I'm trying to do here, I.csv. And I name the new data set containing the probabilities and the categories as default underscore n, and I place it in my working directory directly. So, and this is what I've tried to do here. Run it. So if you have done it, then you will get something like this. Here you have the 10,000 respondents. Then this is the probabilities. These are just the new variables that we've just created. So let's come back here. Okay. Then we have to carry out some diagnostic tests. A good starting point is to test for linearity assumption. Linearity means I introduce my predictors in linear form against the dependent variable, which is the log of probability over 1 minus probabilities. So Then I want to run that, my logit against the predictor value. This is what I'm just trying to do here. So here I'm selecting the numeric data sets. In our case now, the balance and the income. Then I provide the column names here. Then I try to draw, to plot the logit against the predictor values using ggplot. So let's try and do that. So let's try and do that here. See, good. So let's run. So and let's wait a bit. You know, it may take um some time, because but the moment you see this red button here, it's saying please wait, I'm doing some calculation. So try to be a little bit patient with it. And in this case, don't forget we're actually dealing with 10,000 10,000 customers. So let's look at the plots. Yeah. So the plot is, this one come up. Yeah. Good. So here we can see that the points lie the points lie on the straight line in case of balance. So we have no problem introducing balance in linear form. But to introduce income in linear form, no, no, it's not right, because we can see the points. These are probabilities generated. So our interest is these two variables. So if we have this kind of situation, one, it may be because of endogeneity problem. And if that should be the case, then peradventure you may want to consider running instrumental for probit model. Or in the list, maybe you should try to include maybe quadratic or cubic terms of the income and see what difference is going to make in your model. But definitely introducing income in linear form is questionable here. But let us continue as if we don't have problem. So another test we need to carry out is test for influential observation. So we want to consider to see outliers that could be considered as influential observations. And to do that, we need to filter the absolute values of the standard residual that are greater than 3. So to do that, let's come here and run. So now if you look at it, here we have 12, but it's telling us we have with 5 more variables. So I add this 5 plus 12, which means I have about 17 outliers. So one thing I can do, because I don't know the respondents. So in order to identify the respondent, I need to plot what is called, we normally call it Cook distance graph. So this is what I have here. So here I say, okay, give me the top 12 Cook distance, then please plot the cook distance. Run. So this is the cook distance. So we are now, let me zoom in so that we can easily see um, what is actually going on. And to make the interpretation very simple. So here, I'm interested in customer number 652, customer 4,160, 3977, and so on. Customer 9,874, and so on. So, and my candid advice has always been, look, go back to the data set. These are outliers. And be sure that they are truly outliers and the fault is not coming from you, because it could actually be due to problem with data cleaning. So you may look at it, peradventure maybe you want to type 60 and you type 600 and sort of things happening. So first look at it and be sure that it's a genuine case before you think of maybe econometric solution to the problem. But if you now discover that, look, these are outliers based on maybe the interview conducted or something, then one thing you can do, at least in order to control that, is you can actually run what is called robustic a robust logistic regression. Robust logistic regression. And I need to thank one of the viewers of my last posting. In fact, it was through him that I discovered that it could be called a robit. So it's a robit regression. So, and the easiest way to run that, I'm not doing that here. Maybe if we have time, next time, maybe I can go through it so that we understand how to do it. The easiest way to do it is to use GLM ROB. So there is GLM ROB. That is GLM robust. So instead of using the GLM here. So, and in order to do that, I think maybe some other time we can actually look at it and see how it is actually done. But for sure, now we see clearly that we have problem. But my mistake is first look at your data clearly. Another thing is that now we have 10,000 customers. That is, we have 10,000 observations. What will happen if I remove just, because I have just about 17 of them maximum. This is just 12 of them. What will happen if I remove these influential observations? Since I have a very large data set, sometimes you can try and try that and see. Maybe it's going to improve your results, and you can claim that, okay, these are outliers, and you have deleted the observations. And but usually my candid advice for whosoever is estimating the model, whether logistic or regression or whichever model you are estimating, never delete more than 5% of your data set. But in our case now, it's not even up to 1%. So we can still maybe try it and see. Now again, you need to test for multicollinearity. So, and that is why we load the car package. So car means companion of applied regression. So here we have VIF. This is showing you that VIF is in car. I think we are familiar with that, but it's good for me to repeat it. So let's run and test for multicollinearity and be sure whether we have the problem too. So now we have 1.0 for the same value for balance and income. the rule of thumb here is that if the value is not up to 5, then multicollinearity is not a problem. So in our own situation now, you can see 1.04 to mean is manageable. Then we need the goodness of fit tests. So let us get the pseudo PR2AI is pseudo R squared. So and that is why we get this from the PSCL package. So let's run it and see. Yeah. So my interest is this McFadden, which anyway you can actually interpret the log likelihood, whichever. But whatever you want to interpret here, let's be properly guided. It's very, very useful when you are comparing the effect of adding more variables. So the best way to interpret it is maybe you add another variable now. Let's say, for instance, now I decide to add the quadratic term of the income, which means I now have two models. Maybe I call the new one model 2. So which means for the first model, I'm going to have my pseudo R squared. I will have the pseudo R squared for the second one. So then I will now select one with the highest McFadden. That is the best way to handle this, whether you are using like likelihood or something. But if you just want interpretation for just one variable and you are not really considering more than one, some scholars has actually said that if you have value greater than 0.2, that is okay. Yeah. But to me, the best way to interpret it is to fix more models and now try to compare. Or another thing, I think anytime I'm teaching these this logistic, I mean logistic, probit, or whatever models, limited dependent variables regression. What I normally try to do is, okay, how do you choose between probits and logits? How do you choose the model? The best way is you use this kind of diagnostic test in order to compare. For instance, now I run my probit, I obtain the McFadden. I run my logit, I obtain the McFadden. I obtain my archaic information criteria, Bayesian information criteria, and all sorts of these models likelihood. Then I look at the results. Then I use those ones in order to select the best model to use. That is the appropriate thing to do, rather than just the use of rules of thumbs. So like I said, where you can actually interpret the odds ratio or the margin analysis. If you want to get the odds ratio, the odds ratio is the exponential of the coefficients. So I have here EXP model 1. If I put dollar, it's going to list so many things, then you pick coefficients. So we run it. Good. So I have the value here. How do you interpret this value? This is 1.005 and this is 1.000000002 and so on. So to interpret this, this is greater than 1. So this is showing you that increase in your balance actually the probability here, you remove this from 1, that is 0.005 is very, very low actually. So the probability increases by 0.005 if your balance is increased by, the unit you are using, maybe naira or whichever. The same apply to this. But we can see that the increase in probability is very, very small in both cases, actually. So the odd ratio, I'm sorry, the odd ratio, this is the odd ratio, I'm sorry. The odd ratio increased by this much. Odd ratio is very, not the probability. But if you want to really interpret it in terms of marginal analysis, in terms of probability, then you have to come here. You do the marginal analysis. That is why we introduced the MFX. MFX, what is it called? Package. So you run it, and to me, this is the easiest to understand, and what I normally recommend for students to use. Either you use this odd ratio or you use the marginal analysis, whichever one pleases you. In this case, you are actually interpreting the odd ratio, because the odd ratio here will increase by 0.005 or multiply it by 100. So maybe that's 0.5%, whichever, if your balance is increased by a unit, because this is continuous variable. So let's run this. Yeah, we can see that our df dx here is 0.0000, because this is 1.2292 multiplied by 10 to the power minus 5. So again, but you now interpret this in terms of probability, which is very straightforward. Anybody can understand this. That is, increase in balance by units will increase my probability of default by 0.000. So the increase is very, very minute, actually. Yeah. So this is just what I want us to understand with respect to logistic regression, and you can take it from there, or you can take it from there yourself. Anyway, you can learn so many things. The advantage of R is that even the resources to learn some of these things are actually free. You can go to the internet. If you just type it on your Google, you can get a lot of information. But though it takes time, it takes patience, and so on and so forth to fully understand it. And everything is absolutely free. And that is the beauty. You see, it's not that other software like Starter, SPSS, SAS, it's not that they cannot do it. They can actually do it, but it comes at a cost, because definitely you have to purchase and keep updating. And another advantage of R is web, and that is the one that is highly integrated type of software, because I use it for statistics, for econometrics, for teaching mathematical economics, for teaching mathematical programming, for teaching operation research, anything quantitative. So easy for me. Even recently, I'm using it to teach some aspect of farm management, which has to do with this investment appraiser. You talk of calculating depreciation. As a fact, can do so many things. This is the beauty. So instead of running from one software to another, then you can just stick to this. When I'm dealing with time series, for instance, I use it for whatever I want to do, whether co-integration test, whether I want to do a Riemann or anything. You see, so I think it's very, very straightforward and very helpful, since you are not actually paying for the usage. The only thing you need to do is you take your time and learn. And I've discovered if you devote around 100 hours to study R, first, you become an expert. In fact, far, 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 far better than me. Yeah. So thank you very much. Till we meet again. Again, I say thank you for being patient enough to go through this, because this is almost 30 minutes